Swayam Prabha. Digital India. Educated India.
Welcome back. In the last class, we introduced about the transportation machinery for underground mines. We have got the broad classifications and then what are the systems there. So, today we will be discussing one particular type of haulage system, which is a very old one, and it has been there in the mines for even in the 19th century. And that is called a rope haulage, which is a very simple system, but it has before the large scale mechanization came to mining industry, this was a means of transportation, and most of the coal which were produced during the industrial revolution, when this the textile industry were at the peak. At that time, most of the looms which were run by coal, that coal were owned from the mines by this type of haulage system. However, this is still being used in many of the underground coal mines around the world, including India. So, we need to know this system about as academically, that how it grew, and also how we can switch over to a better system from this, and how exactly the changes have taken place. So, we will briefly discuss what this system is. So, that we know already, we told that rope haulage is the means for moving loaded and empty mine cars by use of wear rope. You are using the steel wear rope, and on that you are just making it to, you are drawing the all loaded cars or the empty cars just by tying at its end, and then you are connecting it to a winch system. Basically the drive will be, we are having a drum on which this rope is wound. The one end of the rope is anchored in the drum, the other end is connected to the cars. So, you can see here in this diagram that how a mine car is connected to a rope by a lashing chain here, it is getting connected. So, this type of small mine cars which will be running over rails. So, the transportation, as you can see here, that is as your rails are there, tracks are maintained in underground mines, and over that these mine cars are pulled. So, we will be in this class just classify what are the different type of this rope haulage systems are there, and a particular type called your direct rope haulage, the oldest one we will be discussing today. So, as you can see here, that is rope haulage classifications can be done as a direct rope haulage, in which whether the rope is drawn by a single drum direct rope haulage, or sometimes you will use two drums for the rope winch system, there it is called double drum rope haulage system. And there is a main and tail rope, we will be knowing it in the next class. We will be discussing more about this main and tail rope or the endless rope haulage, which are little advanced than this. Then this endless rope haulage, it can be again an under rope haulage or a over rope haulage. Under rope means if this, as you show here, here it is a over rope, that rope is exactly above the truck, that is your in the haul road, it will be rope is moving at the top of the trolley, and then you are connecting over there. Or it could be this rope, if it is just running at the near the level of the track and you are connecting over there, then it is called your under rope. So, this and then another is your gravity rope haulage, where you are required to take the material down. In that case, actually it will be by gravity that your system will be pulled. Sometimes it is there. Suppose you have got number of empty cars, their total load can be, that is your equal to the weight of the loaded truck or little more. Then while your empty trucks are going down into the mine, their load will be pulling the your few loaded tubs on the top. So, this is the way by gravity you are using without giving any additional power. You will be only using some mechanical braking on that system. Such type of systems are also there in the rope haulage. So, what is the rope haulage system? Then you can think this way, the pulling of the loaded tubs up the incline. Incline means that in an underground you are going in a inclined shaft, that on that incline, if you are just pulling the mine tubs up, that is with the help of a rope, and the empty tubs, they will be going down and loaded tubs will be coming up, that is the system. And that is what are the component it will include? It will have to have a mine car or tub, it will have to have a railway track, it will require that wire rope and that pulley above which this rope will be moving, or then exactly that pulley on which you will have to give the drive, that is you will have to connect the motor with a gearbox, and that pulley it will by the rope will be just getting the power of the motor because of the friction at the pulley and the rope. So, that is the way how it would be there. In some cases it will be the drum on which this rope will be wound up, and then the rope haulage system is mechanical and incorporates robust equipment and such and finds application in underground mining applications of different type. It is also used, that rope haulage is also used in some of the construction sites or some of the quarries for some other transportation means also. Sometimes we make a very temporary short arrangements of moving some bulk material in the surface also, this type of systems are used. So, this table summarily tell what are the you can classify this system on the basis of your single group of cars with two group of cars, the numerous cars, and then drive drum. So, how this is the way how you classify. Now, as I have said already, there the basic system, we are having a track, that is railway, rail tracks, rails will have to be there on the track. Now, this as you have seen in any railway system, that if you see the rails are mounted on some sleeper. Invariably earlier it was wooden sleeper, nowadays we are having concrete or metallic sleepers are there, and these rails which are again that they are specified on the basis of what is the total per meter, how much is kg. You may see that some of the very high speed train, when they move, there are exactly the rails which will have to have almost 75 kg per meter is a weight, big heavy rail, or some light rails are there where you can have just 37 or 40 kilo per meter, or even sometimes a smaller very light rails are there in some of these mining applications. And that cross section of the rail you can see over here, that different type of, this is just like a T sections, or we are having this base, it is connected to the sleeper, you are anchoring here with the help of this clip or sometimes with this your pin nut, and then depending on the size of the and depending on the load, there could be a different thing. And then one thing is there, that the rail cross sections, actually even in underground or in any railway, you will find that the rails are placed over here, that on the side, that is your mainly the formation which is called the subgrade. Above the subgrade you are having a ballast, sub ballast, and then above that is that ballast. You might have seen that in the railway line you see a lot of stones, that stone ships are there, that is called the ballast. It has got the purpose of its absorbing shocks and all, and then above that how the rails are fitted to this slipper depending on the type of things. The rails could be of different type, like it has got that flat bottom rail or bullhead rail or grooved tram rail. Different rails are there in your surface, heavy duty rails you have seen. But basically in underground mines, in that small also, we will have to consider in that what should be the head, what should be this wave, and what will be the foot. And then this car, that is a mine cars, they will be sitting on the slipper, and that is exactly what is the your width of this wave, that will determine exactly how much weight will be coming. And that the mine cars or tub, they will be having 2 axles, and on these 2 axles your wheel is connected. This is having, the wheels are normally having a little bit tapering over here, and that is why at the top of the rail you will see there is a curve. So, that curve will be matching with that the curve at the wheel, and the wheel will be having one flange. That is, now that when the mine car will be resting on this, you can see here there are 2 styles are there. One is the inner style or the outer style. That is this will be in which way your your mine cars will be placed. That will be having a lot of things. Now, how will negotiate curve, how this load will be there, and then how exactly that what should be the strength of anchoring this your rail onto the slipper, what type of clipping should be there, and then what type of dangers may come. Because if this is not properly anchored, and then it is particularly if you are making it going at a very high speed, at that time this get coming out of the rail, means there will be the derailment. Many of the accidents take place exactly how the rails are connected over there, how the performance of the track is there. So, though it is a very small scale railway, but just like the main railway, we need to see over here in an underground also you will have to maintain the railway track, and there this clip by which you will be connecting the rail onto the slipper is very, very important. As in in your normal railway on the surface rail, when it goes, we have got different type of clips. This E clip, which is very common, in that you can see that even that for connecting it, there are 4 components of the how this rail will be connected over there. There is one is called this clip part, which is there with an insulator, that is exactly there in between your shoulder and that rail pad. We are having one insulator clipped over here. You can see here, this is the insulator, and then how the rail will be going. Then there is another type of clip which is called a nabla clip. You can see here nabla clip, a different type of plate with a hole, it is there. Through this hole, this nut will be going. Below the nut, there will be a washer, and then a screw at the pike, it is going down over there, and below this your slipper, it is keeping it tight like that. So, there are again a different type of a scale clip, which is having again this clip component. There also have this your screw or dowel is there, that, and then there also same like your other clip, we are having connecting these things to that your rail is connected to the slipper, and then it is anchored to the system, so that it does not get jump. So, there is again a very special type of very heavy duty connections. These are not in the underground mine, you do not use like that, but you should know that how our railway slippers and railway clipping systems are there. But one thing you can see in underground mine, you can see over here, this is a scene from an underground mine, where light steel rail or railway mine tracks are put over here. This exactly when they will be railway cars will be coming from one, that is your in a room and pillar method, from one district when it is coming, and then they are connecting into that main. This will be the main your gallery through which it will be put, and you can see here how the switches are there, so that it can be connected, that where if the rail coming from these directions, if it is to go over here, this switch will be operating, this will be pushed to connect over here, and then the track will be changed. So, you can see that this is manually also done in the mines, that people will be pushing the car over here, the 2 to 3 ton of material will be done in that railway siding part in the underground. So, that the material is carried and put, and there will be the 2 cars, they will be connected by coupler, and then from the front they will be connecting to the either this rope by a lashing chain and clip. So, now we have seen in that basic system of your rail, track, car, and then the driving system is the rope. Now, the most common thing is your direct or main rope haulage. Now, it is what is there at a higher elevation in the mine, then your material from carrying down from the bottom, it is being pulled up like this. So, where it is getting pulled at that time, that is you are having a drum, and this is the rope, and here suppose your mine face is working over here. You are having 2 tracks. Now, when this your these are loaded cars, or this loaded cars will be pulled like this, and it will be coming over here. From here they will be disconnected from that rope, and it will be pushed to the cage, and that car will be taken up, and the empty car whichever will be coming from the cage will be brought over here in that siding, and then they will be pushed, and they will be connected to the rope, and it will be lowered down in the case. So, see, this is where how the with your drum you are connecting, it could be one that it is just bringing up to here. After bringing up, this drum is given by power, and then when the material is collected, at that time again that mine cars will be connected to the rope, and then by gravity it will get unwind and go down. And there could be 2 drums, one is when it is this loaded is coming up, the other that is your empties are going down. So, by that what is there, we are doing a balancing, that the motor power required will be reduced by using this your, while using the power of empties going down to pull the partially the power required for pulling up is given, and that is why it is called your direct main rope haulage. So, that in case of the single drum, the engine hauls up journey of loaded cars, then the empties are connected to the rope and return to the bottom by gravity. So, what is required here, when you are bringing it up near that shaft, that is called your pit bottom. In one of this, maybe we will be coming in the next class, I will giving you the layout of what will be that in the pit bottom and pit top, how the layout will be made for doing this transportation system, because that is very important. The operations will have to be arranged in such a way that in an underground space, how will you create the space for that empties to go, and then that is we will be placing the empties which are coming from the cage at one place, and all the your empty will be putting down, and when the loaded are coming, you will have to have a place for keeping them separately, and then to pushing them to the shaft. So, that arrangement which is done, that is called your in the shaft bottom or the pit bottom layout for doing this haulage system. So, this type of direct rope haulage system, it is used on gradients sufficient to pull the empty cars and single rope down the incline. So, your all system cannot be used everywhere, we will have to calculate in that particular mine your in which way from the bottom you have arranged, that is your when the shaft is going vertically down, from there then your mining is going on somewhere down below, then from there up to here how it is put. You may be having your that haulage drum somewhere over there, it is coming from there, it is coming, and when at a particular point it will be disconnected from the rope and it will be brought towards that. So, there will be a level side up to the level point, it will be brought by the your incline through this rope haulage. So, the application of this system it will be first, it will be depending on how the underground mine is designed, and then power is required only to raise the loaded cars. This is done in such a way that when your empties will be going down by itself, you will not be requiring power, and the minimum gradient in good condition is 1 in 25, that is, and then your for bed road conditions this can be 1 in 10. Now, what is this bed road conditions means? You may be having the incline, but in an underground mine it is very difficult to maintain the road if we do not know if the mine is having a lot of water percolation, and then the floor of the mine, what type of rock is there we do not know. If it is having a lot of shale, then when this water comes it swells. So, that is why the track can be undulated, and then there are many times the roof they may fall and rock and all that thing may coming over there, maintaining in a very small side, sometimes the resistances and all will be difficult, and because of these things. Moreover, sometimes because maintaining the geotechnical pressures underground also lot of conditions may coming, but a good road in an underground mine is, of course, in a metal mine when this is a competent rock, no much problem, no water is also not there, they are maintaining a track and all could be very good and safe, and also it could be maintained very nicely. So, that depending on the mining conditions you may have a different thing, and then your many time in underground mine you use this man riding car. Here in this diagram give a good illustration of how the system is introduced. You can see here you are having a motor, and then this is the whole driving drum where you are having the braking system, and that is a brake is the only control, or you can have a gearbox to make it at a different speed, that system could be there, and this rope is wound on this drum. And you can see here this is a rope is an under rope, or here and there we are having one rope which is over here. So, this rope it is connecting at this point, but there is with the help of this pantograph we are having this on the roof, you are connecting that, and this rope is going all you are having there, your man riding cars are here, and your rope is anchoring onto this car. So, you can have even that your electronic communication systems, your pagers, all these things could be there. So, only thing that your man riding cars are coupled by the coupler over here, and you can carry it like this. So, when this is to go down, it will be just controlled by its own weight, it will be going in these directions. So, this type of systems are used in underground mining. So, if you see that what are the main features of this, the common features of the direct rope haulage systems are the rope is anchored to the drum and wound by its rotation. The haulage engine is mounted on the center line of the track and the top of an inclined roadway. Power to the rope drum is supplied from an induction motor. The empty cars are lowered by gravity, and therefore, the drum shaft is provided with jaw clutch for disengaging from engine. Very simple mechanism. We are having the motor, from that you are just connecting that engine to your drum, and drum can be rotated by this motor with that simple you can clutch and declutch for when you are keeping it going down, you are declutch from it, and by its own gravity it will be pulled, the rope will be going down and the materials will go down. The speed it can go up to 8 to 12 kilometer per hour, and the brakes are essential to control the rate of return of the descending rope, because by acceleration due to gravity, depending on the degree of inclinations, the downgoing cars will be it will be accelerating and will be attaining a speed. At that speed, what may happen, that is from the rail it may get topple out. So, that is why you should not allow to increase the speed beyond the limit, and there you will have to apply this brake which will have to be used there. Then you have your for these things you do need only one track. So, gallery need not be very wide, because in that track, that when it will be going, and then in the same track the loaded turf will be coming. So, that is why a single track. Now, this is a very important thing, because in underground maintaining the haulage means your how exactly you will have to excavate that thing and then go it out. If it is a wider road, that means you will have to get wider material that to take it out, whether it will be able to support the roof and all, there is a condition. So, a lot of geotechnical and safety conditions will have to be looked into. The rope is carried on rollers, that is the rope which will be pulling and down. Now, when it is there, that between the track there will have to be some rollers, otherwise the rope will be having a frictions with the track, that road material, it will get wearing out. But when you are making some rollers over there, this rope will go, and that rollers there you will be keeping proper lubrication, so that the rope wires do not get worn out, because if the wires of the rope get worn out and come out, then the strength will be decreased and the rope may get broken, and then it will be leading to accident and failure. The cars are manually coupled and uncoupled from the rope. You will have to require persons to connect and disconnect, and average speed you can go this as we have said 8 to 12, but sometimes the maximum will not go beyond 18 kilometer per hour. And as because each and every tub will have to be connecting, disconnecting, from bringing from the face to the haulage systems by pushing it manually, at the end also disconnecting it, then pushing it manually, taking it to the cage. Because of this, you will be hearing that in underground mining a large number of laborers need to work, miners numbers are more, and that is the reason why many of the mines in our coal mining, the underground mines are always making loss or very less profit, because huge number of persons are working, and today they will have to be given the salary and all that thing as per our labor law. And because of that, many of these mines operating with these systems do not become viable, and number of underground mines have got closed down. And India, that is why today not even 5% of its total production is coming from the underground mine, because the mines did not get changed to adopt a better technology and then to do this challenging job quite differently. So, that is where your the systems will have to be improved. That the components of the rope haulage, as I have already told you, that is wear ropes, rope clips, rope capel. Rope capel means how the rope will be that exactly terminated, that how in the drum that rope will have to be fixed, and then how that is done, that is your exactly you are anchoring the rope within the drum by using a rope capel called short capel and all. That is a different, maybe in the winding sections we may discuss about it. That cars, that will be your single or in a set of car can be done with the help of coupling. Railway track system I told you. Haulage engine, basically it will be electric drive, their control equipment, gear, surge wheel and the haulage brake drums. These are the main things. And if you see the features of this, it is a labor intensive, operates safely and economically when other systems fail. It is very simple. So, you can have a control over here, and easy for speed control, can be operated by less skilled persons, no much bigger technology, it can be used over here. So, that this rope haulage can be by this drum, this can be single drum or double drum, and there could be depending on that rope drum, it can be a small rope drum or it can be a bigger rope drum. It is having a that is your conical drums, biconical drums, you have got bobbin type, you have got a sheave or pulley type, just lot of different way these ropes can be given the drive. This that normally this drum on which it is there you connect the powering system. So, The double drum direct rope haulage is a balanced system. This is called a balanced system. In this system, 2 drums are mounted on the single shaft. You can see over here, and then one drum winds up the train of loaded tub, other one is allowing this empty tubs to go down. The weight of the tubs and the ropes are balanced, and the unbalanced load for the haulage engine is generally the weight of the material hauled. That much only the power which will be required. The peak power consumption in this system is lower than the single rope direct haulage. Moreover, braking is also easier in this case. The production rate is also twice that of the single drum haulage. However, this system requires wider haulage road, because if a 2 lines to go, that means 2 tracks are there. If we put the 2 tracks, the gallery width will have to be increased. So, there are many advantages, because it is a simple and a flexible, you can easily install the operations are you can easily instruct, even the unskilled manpower can make the whole system working, and it is a consistent with the needs of ventilation and travelling. Whatever your ventilation, we are sending air to the underground mines, with that same air it does not create much problem, say, because it is not having any diesel engines or anything by which exactly you need to give a more concerns of the ventilation design. Then a large number of cars and trucks are not locked up in the rope, because in endless we will discuss later that there number of cars may be connected on the whole system. Here it is not, it is in a one train, that train is going and that other train is coming up. So, you are at any time all things are under control, and the one problem is that derailment do take place here, because while going it down, this is an unmanned system, normally that is to it get derailed, and for that lot of precautions and then lot of safety provisions are made. By that only it can work better. So, the main thing, the power of the engine is large for a given output, you will have to more energy will be required there, but it's a, because it will be working at a high speed and tubs are unbalanced, because of that your power requirement goes high. Then acceleration offering higher peak loads due to the drum gearing and rolling stock inertia. For that you can calculate out how much will be the energy required, considering the frictions and the conditions over there. The heavy braking is required, because for avoid overspeeding. Then with heavy trains of large cars, the components of the system may become heavier and larger, and this may present operating difficulties, especially at the transfer from full to empty train, when they will have to be loaded. At the siding you will have to do a lot of work management. Then the haulage engine takes more space than endless rope haulage. Here you will have to excavate in the underground mine, you will have to keep some space for connecting for placing that, mounting the motor, gearbox, drum, brake, road system, and from there again to connecting to the rope, and then making a siding for the place where your loaded cars will be coming, where you will be placing the empty cars, and then those empties how it will be connected to the rope. For that lot of space arrangement will have to be made in the underground system. So, this sometimes create certain disadvantages. Now, this terminal arrangement, that means when they are bringing up to, this is the drum positions, exactly from the bottom when it is brought up, we always give a crossings. This part will have to be excavated, that is in the underground you will have to make some space in the area, another short gallery in which these empties will be, this loaded will be coming, and then they will be placed over here, and then when it will be taken from here to the shaft, that if the shaft is here, after that the empties will be brought over here in another line, and then these empties will be connected to this rope and go. So, this arrangement which is called your sandbag landing system, that will have to be made. So, this is sandbag landing system. In this system the full train is drawn over the crossing, and when all the tubs are above the crossing, they are lowered back and are diverted by the crossing into a siding at an angle to the main road. So, these arrangements exactly as a mechanical engineer or any other engineer who is going to work over there, they need to know now how that space excavation the mine has been planned in underground, particularly near the shaft, how the crossing has been given and how the layout is there, that you will have to understand. Then there is and the work component which is there, that they will have to, the rope is to be transferred to the empty train and then on the parallel track in the siding. So, that pit bottom layout, that will have to be properly designed. This when they will be doing that, you are using the gravity for lowering the your empties. So, you will have to see that how many numbers will be connecting to there, so that it should not get over speeded. If you give a number of things, the weight will be increasing, it will be, so those that care should be taken over there. So, the empty train is first hauled up and the sandbag incline. It ensures that all the tubs are coupled before the train descends the main road. When the empty train comes to the lower crossing and allowed to take the positions parallel to the full tubs, the rope is then detached from the empty train and connected to the full train. The full train is then pulled, that is at the bottom part of the thing. So, these are the very simple arrangement of this particular system. There are books, but these systems were very well described as an old system. So, if you get hold of that Statham's coal mining practice of very old days, there these are discussed. But this I am telling you for your the understanding of this whole system, that rope haulage, how it has developed, we will be discussing this part only, and from there that what are the modern systems, how we will be incorporating over there, we will have to do it. So, here you need not put much effort to learn the systems in detail, but some simple calculations of how that it is done for your academic understanding will be necessary. So, this as today we have discussed the application of rope haulage in the mines, and basic tracks are explained over here, and the direct rope haulage is encouraged. In our next class also we are going to discuss some of the rope haulage systems only. Thank you.